So, good morning, and thanks for joining me. It's great to be here. It's my fourth time in Build Stuff as a speaker audience, so it's great to be here and see so many familiar faces, and thanks for joining. So, let me introduce myself. I'm a solution architect for a company called ASOS. ASOS is a global fashion retailer, and it's essentially has taken over the Marks & Spencer as UK's largest fashion retailer. And what I do is that I work as a solution architect for recommendations platform. And what we do is we essentially take the user interactions and turn them into personalized experience using machine learning. Just to give you a kind of scale that we have to operate in, this coming Black Friday, in a couple of weeks, we are expecting on one of our APIs around 1,200 requests per second at peak, and this is while it hasn't been fully utilized. So next year, we're expecting a lot more. Some of the APIs are expecting around 10,000 requests per second. So I was a Microsoft MVP, so my claim to fame was short-lived, but I have been very active in the API and REST community. I've contributed to this book. And what we're going to do today is, because RPC is very old, and the criticism to RPC also very old, we have to look at the history. After this, we're going to look at the forces behind RPC's resurgence. And then we're going to look at an example with some sampled codes, so you will be able to see some code, it's not just talk, that we're going to break down a very simple example using GRPC. And in the end, we're going to look at the RPC versus REST and the fallacies around it. I don't know if it is a sign of the age, but I've recently been very interested in history. I generally believe that patterns do repeat themselves in history. For example, you probably are familiar with the tulip mania in 1630s and how it exactly mapped out the elements of financial crash, something that we might witness soon with cryptocurrencies, perhaps. Who knows? But so this, I want to go back long time before that, so they found this very old sketchbook in France, which dated back to 1230s, around 800 years ago, and this belonged to a man called Villard-d'Ornecourt, and for those French people, if I butchered his name, I'm sorry, but he was a man that lived around kind of today's Paris area and seemed to be familiar with the architecture. And his sketchbooks actually teaches us a lot about how people lived and how people thought. And the sketchbook has many interesting pictures, and some of them clearly shows grasp of perspective, which is for the time is quite impressive. But the most famous of all sketches was the one at the right, which is showing a perpetual motion machine. So perpetual motion machine was a device, as you can expect, that basically, with no energy input, can maintain the motion indefinitely. The first reference is actually, we have to go a century back to India, Pescara, where he was the first person to actually describe Pescara Wheel. And the one in the middle you see is Tocola's overbalance wheel. Through the centuries, many small and large models of it was built, but as you can expect, they didn't live up to expectation. Even Leonardo da Vinci was very interested and fascinated by it, and created some sketches of it which survive until today. But hold that thought for a bit, because we have to go back to it in the end. And I'm going to take you through the history, through the centuries to 1970s, and to be exact, 1976. At this time, as you can see, there was a lot happening in the world. But in the meantime, some people at ARPANET trying to connect their computers, which were mainframe. And as you probably know, ARPANET is grandfather of today's internet. So they're trying to connect these mainframes and share their resources. And in fact, they have been trying to do that since 1972. But they felt they needed a framework, a protocol. So James E. White comes up with RFC 707, proposes a function-oriented protocol, and he calls it PCP, or Procedure Call Protocol. And as we would read here, it essentially would elevate task of creating applications to defining procedures, and would encourage and facilitate the work of the programmer by extending local resources by remote ones. And this RFC is known as the first draft of what would known to be RPC, although the name would come in 5 years later. This draft would advocate modeling resources as operations. I cannot think history could have been even more ironic, because in 2 decades, we would try to do exactly the opposite with the rest. But anyhow, the crux of this approach is a protocol and a runtime environment, which makes the remote resources look like local. And as you can imagine, the protocol itself wasn't very elaborate. It was primitive compared to the systems we have today. They defined request and response with these kind of optional transaction ID, results, pretty much everything you expect. They did mention 2 problems. One of them is that, yes, it looks like the same, but remote calls are expensive. And the other one essentially was the problem of control, because locally the control flow is known and fixed. In the remote systems, it's not. But the gold standard of RPC would come with Birrell and Nelson in 1984, and became the de facto recipe for RPC system. Nelson, in fact, himself spent his thesis on that and published in 1981. And these two actually had all the right to publish this paper, which essentially because they had built one using the Cedar programming language. And this diagram is taken from one of the pages of the paper, and as you can see, probably recognize this workflow, which is very much similar to what you would have in RPC today. Although their work was significant, and even they had security, but it was single-threaded and specific to Xerox PARC environment and, small LANs. But criticism, it's funny that RPC is one of those first things that the criticism came before. So this is a very nice reading, and although it's from 75, I highly recommend. And Richard Chance, he said PCP is not going to make building distributed systems easier. And as you can see, so it can neither directly nor accurately model the interactions and control structure that occur in many distributed computer systems. And he essentially outlined 10 different problems, and I highlight some of them here. For example, recovery from component malfunction. Who in this room hasn't dealt with that? Sequence of procedures, if you have to call them in order. This is about granularity of the API design, parallelism, synchronization, This fourth item essentially is talking about streaming, lack of streaming. This one, lack of queuing, priority, and essentially didn't have any security. This is a fascinating read. Another one, 1988, two Dutch computer scientists published this paper, and they start with saying, they started their paper with saying that, RPCs achieved sacred cow status. And they basically divided the problems into conceptual, technical, and performance. And in the end, they basically target the heart of RPC. And they are saying that, yes, you can make this transparent, but there will be problems, and you can code to get around those kind of problems, but then transparency is lost. And if transparency is lost, you would wonder actually this kind of model of semi-transparent model is doing any benefit for RPC. The last one I want to refer to is actually reads very much like it was written yesterday, because a few years past, TCP/IP became quite popular. Network-based systems started crop around here and there, but then came object-oriented programming and Java, and now people started talking about remote objects rather than remote procedures. So the first thing that came up around that was CORBA, which is Common Object Request Broker Architecture. So Jim Waldo joined the force, started working with it. He wasn't really happy where it was going, and in the end he was so frustrated that essentially rage quit. And this is kind of his "I'm leaving .NET" thing, that it's not. It turns out .NET developers, they are not the people who invented "I'm leaving X," but it, as I said, reads quite nicely. It's one of the good papers, and says that we argue that objects that are that interact in a discrete system intrinsically different. And then he goes on to say that communication between parts of the discrete systems is not a problem. Actually, connecting systems to each other is not a big deal. But the problem is dealing with all these distributed problems, distributed computing problems that we face every day. And in the end, they say, rather than trying to merge the local and remote, we just need to remind it constantly that they are different. RFC, there was another RFC came up. They had an opportunity to fix some of the problems, but they really didn't. And I just mentioned for the reference here. So late 90s, CORBA and DCOM were very popular, and people started to talk about how they can communicate these. And XML was here to save the world. Anyone here from those days remember the XML fanaticism? It was those days. Everyone felt, oh man, everything has to be XML, and it's kind of quite unfortunate that REST came out around 1999, 2000, and SOAP's first draft was in year 2000, and spoiled distributed computing for all of us. But it was only around 2007 that we recognized, all of this kind of overhead that we're building into SOAP is basically essentially counterproductive. But this is from Steve Winovsky from 2002, and he recognizes, even back then, that REST is the correct solution for the web. So, we've lived through REST domination for a decade, and What made some people to go back, try to think about RPC? And as I will explain, you will recognize that it has little to do with any shortcoming of RPC as an architectural style. And it's more to do as a culmination of various industry forces that making RPC a more practical choice. And I will try to mention some of them. So one of the reasons RPC made a comeback was because they never went away. So Google has been using RPC internally and using Stubby. Facebook and Uber, they have been using Thrift, and Twitter, Finagle. So it is true that REST APIs have been used publicly. You probably have used the public API, but internally it has been all RPC. Containers. Anyone here using containers? Yeah, a few hands. Who is using more than 100? Well, I see one hand. Who is using more than 10,000? Anyone? Okay. So people who are using containers at that level will tell you that is the biggest problem with using containers in that scale. Essentially, the traditional networking melts down under the pressure. And Google has been, a few years ago, said that they are running 2 billion containers every week. And so they have been all trying to make this more efficient, and HTTP2 is something that they've been working on. And HTTP allows for reuse and multiplexing. So it is much softer on network. And that's one of the reasons they are coming up with this. And obviously, you know that for everything there is a host, but host runs different VMs, and then you run different containers. The reality is everything has to go through the same handful physical network interfaces. People have come up with different ways of solving this. You might have heard about it. Overlay, underlay. So the bridge networking is the default one, but overlay, underlay is another one. James Nugent is going to talk more about networking. I think that's a session in case you're interested. Microservices. So I don't know who was here. Last year I had a talk about microservices. Anyone here from last year? Yeah, I think a couple of people. So we talked about the outliers of performance. And the outliers of performance is essentially what you're trying to target. And if you can reduce that using a more performant method is an option you would take. If you're running many containers, if you can make that more efficient, it means more costs. Now, one of the good things about REST, probably you've known, is how this is very important about evolvability. But then you look at the RPC, it's not evolvable, but people are looking at actually adopting it for the safety. Uber is one of those ones. They basically found that the poor performance and inconsistencies within their REST API, they made them decide to move to Thrift. And also enforcing governance. Again, Uber was a good example. I've put these kind of blog posts there if you want to have a read more. But essentially, they use this to enforce governance on their teams without removing the autonomy. So anyone here does Go, like professionally? There are probably a few people. So it seems like Go, the reason that it's very popular is because of it's very lean. And being lean essentially means cost reduction and having less footprints. And That's the reason that you see in some of these recent papers, when they talk about distributed computing, they just want to use RPC. And this one for machine learning, the other one for blockchain. So this seems to be a trend in there. If someone told you that by using a technique, they're going to increase the lifetime of a battery twice, would you consider it? You'll probably start thinking about it. So I yet haven't seen any kind of empiric evidence, but just anecdotal evidence seems to be piling up that using RPC potentially could help with CPU usage and battery life. And for IoT systems, this is essentially a very important thing. So HTTP2. HTTP2 is more performant. It allows for HTTP compression, header compression. It allows for streaming. We're going to see an example of that. It reuses the same connection and allows for multiplexing. The difference of multiplexing with pipelining, which we had in HTTP 1.1, is that with pipelining you get head-of-line blocking, which means that first request has to come back for the response for the first request has to come back before the rest can be accepted. That problem doesn't exist in here. But now, this is all well and good. Anyone here using HTTP2 on their server side? Between server-server communication. Anyone? Well, that's why. That's why, basically, they're trying to promote RPC, because they're saying that for free, they could start using HTTP2 between your server communication. I mean, if you have looked at the examples, it's actually very, very difficult to write that kind of code to multiplex around various requests and everything. So, decades of distributed computing experience. Yes, I agree. I was having actually a conversation with someone about RPC, and they said, you know, like, if you're saying that RPC is not about local versus remote transparency, then it's not RPC. I think I would agree with that, but, you know, this is what industry is referring currently. And I would tend to look at this in terms of traditional versus true RPC. True RPC is old and is not good. The new RPC is here, I believe, to stay. So with that, let's move on to GRPC as an example of RPC. So I guess you guys have already are aware that GRPC is making noises, and some people are adopting it. Thrift and Finagle, there are two other RPC frameworks. So Thrift are currently mainly used for a serialization platform. Finagle, it's a protocol-agnostic protocol. It's very RPC system. It's very, very good. You plug in HTTP 1, HTTP 2, and it is quite interesting. But it's not as widely adopted as GRPC. So what is GRPC? GRPC relies on HTTP 2 for transport and protobuf as message protocol. And essentially, it's ideal for server-to-server scenarios. However, people are saying actually you can use it on native app and IoT devices. As I said, this is probably an area that we need to look more and better and look for kind of more empiric evidence, but that seems to be going pretty well on server side. So cross-platform, you can use it on 10 different languages, so including C# for those of you who probably .NET developers, and as I have been, reusing the same connection. So we talked about it, you know, if you have so many of these microservices, they're going to connect to each other. You end up with problem if you keep making connections, creating new connections. So this is very useful. Two-way communication through a stream. So it supports server to client streaming, client to server streaming, and kind of two-way streaming. It's very good. We're going to look at an example. Security is through TLS, but if you want authentication or authorization, you have to kind of plug it in yourself. You can write middlewares. It's pretty easy. You know, it's due to, because it's run as HTTP, kind of works pretty well with the with existing kind of authentication scenarios we've had. So let's have a look at the demo. Right, I need to. Okay. So essentially, this is where you start from. This is IDL, but is the protobuf version of the IDL, as you can see. And it's not rocket science, you know, basically you're defining, okay, I've defined my mini service, this is add request, then add request is defined here, what the schema is, and returns add response. Now, I have a streaming case as well, which basically report position. So this is, let's think about like a kind of like Uber scenario, where the driver has to report its position so that they can optimize their algorithms. And then you see you have to define, you know, kind of the ordering. Again, that's specific to protobuf. And in terms of the other one, you know, we have essentially these are two different things. Adding two numbers, and the other one reporting position of the client. Right? What you do, then you have to basically generate. Right, clear. Yeah, you have to generate the code. I can actually delete. So you see, there are two files here, mini GRPC and mini GRPC. So the proto is the protocol, protobuf IDL. And I can delete those C# files and regenerate using this shell script. But bear in mind, this shell script is nothing but it basically uses a tool to generate from IDL. So let me just right, and look at this. Okay, I got rid of them. Now I'm going to run generate proto. Okay, so I got them back. This sample is on my GitHub. I will publish the address. Also, all the slides will be published as well after the talk. But this is .NET Core. I just want to build this. So I go here, .NET build. Right, I'm going to look at the client while it's building at the client and server. So essentially, this is very, very simple. You look at the server here. So all it does is basically does the add. It just sends a response. That's nothing complex. The second one is essentially gets the stream. And what it does then basically iterate through the stream while it can be iterated, and every time it comes out, it just outputs to the console. The program is nothing fancy. You know, that's very simple. The client we have here, so basically client accepts a command line parameter, and then we just create a channel on that particular address. And what we do is that create a client, and they basically do these. So in here, we just client add request, simple. But I've moved this to acid trip. So the client essentially loops 10 times, and every time just changes slightly the coordinates and the reports. Look at here. Essentially, this says at the end that I'm done with the stream. So this notifies the server that, I'm not going to publish anything more. And next line is then it waits for the response and publishes the response. So as you could see, the server was basically outputting, and at the end will say, like bon voyage. So I think we're going to see that. So it's built successfully. I go to server. Right, so .NET run. I need to specify the framework, .NET Core App 2. Anyone using .NET Core yet? I think, yeah, a few people. Right. So it's probably not the fastest thing in the world. So it's come up, server is running. What we're going to do, we're going to add 2 items. Let's just .NET run framework .NET Core App 2. So this will print out, like what we can do. There are 2 options, add and travel. So I'm going to run add now. Yeah. So nothing fancy. So now the travel. Let's review what it actually does. So what it does, the client now can start sending stream of events. You can even build kind of event-driven solutions with it. Now, whether you want to do it, what happens if the connection gets lost, so there are all these kind of aspects of it, but it's just another tool in your toolbox. So we start to travel. The server should receive, okay, it's moving, and here it's publishing. And bear in mind, once the stream is finished, the client says, okay, stream, now close the stream, I'm done, and then server is going to return the response. Okay, here is the node bon voyage. Yeah? Okay, so I think all in all, this is pretty straightforward. The point is that you need a proto file, generate your code, and then just start using it. Okay, so with that, we need to go to the next section of the talk. Okay. REST versus RPC and fallacies. So now, how would you go about actually choosing what to use now? You see some really interesting stuff here. There are some benefits. Would you go and drop using REST APIs? In an industry, what would you do? You would just go and look at the literature. But here, what we're going to do, we find this article. And this article is probably one of the most famous articles here. This has got 74 citations, and it compares REST to RPC. And the authors mentioned 6 different issues with RPC versus REST. But looking at the content, it turns out that they are actually comparing REST to SOAP, not to RPC. And to say the least, is not very accurate. So in terms of scalability, they are saying that, you know, it's a straw man attack at RPC. And essentially they are saying that, well, you know, web is very scalable. You can't make it as a scalable. I mean, Google does RPC all behind the scene, so that is not correct. Coupling. They say that, you know, service contract of RPC style, you know, you have to use a particular kind of service interface that enforces a data format. That's not accurate as well. You know, you can use any kind of serialization with finagle. I mean, one of the reasons GRPC has gone with protobuf is just for simplicity, but I'm sure there is no problem in terms of making that you know, pluggable as well. Security. Does that look like security by obscurity? This is definitely looks like to me. If it is necessary to hide some resource, just don't release its URI. Oh, that's I definitely won't do that. The performance. Performance is one of the advantages of REST. Yes, maybe to SOAP, but it seems the world has changed. So, the other one is that fallacies is when you talk about the performance, the RPC advocates, they come back and say, you know, it's so much better than JSON. But I mean, you don't have to do JSON. HTTP provides content negotiation. You can pass any kind of data format. But who actually here uses anything than JSON for their HTTP? I think 3 people. You know, kind of makes the point. Yes, you can, but no one does. I mean, we are looking at using Avro. Now we are trialing Avro for server-to-server communication. But essentially, you can use anything. The other one is that RPC is here to replace the web. You know, we have had the web, we love it so much, and we don't want that to go away. Well, essentially it's not going to be used for those web scenarios. Does it mean that people are not going to try to use it in that scenario? Right. This chap wants to do RPC in JavaScript from browser. And once the team actually responds to that, okay, this is not in our roadmap, you know, someone says, yes, but it is in our roadmap. So someone is actually building GRPC for web, you know. I don't believe it's going to catch on, and I don't believe it's right, but anyhow, just to know that these kind of things do exist. And the last one is fallacies regarding modern RPCs, you know, make remote calls like local. You know, I really like this comment from 2012 in Hacking News. It's essentially, you know, everyone is doing RPC underneath, not the public APIs, but you know, it's bad because network calls look like local calls, you know, is overused argument. In fact, look at this. There is no resemblance to making a local call, you know. You definitely are dealing with the stream, request stream, you need to complete it. You know, it essentially says that, you know, you're hitting I/O. So that is definitely not the same. So I would recommend thinking like this. Essentially, you know, again, this is just as a guideline, but if you're using microservices, it's one thing to consider. If you are using containers above 1,000 or 10,000, there's one thing to consider. If you are in like a high-frequency trading business, then I guess it looks lucrative. Your domain is highly volatile, so safety becomes something you're interested. So not necessarily, you know, you want to evolve, but you are in full control of both client and server. So that's important. Enforcing practice across microservices. So essentially, your mileage may vary, but this is a kind of a very rough guideline. Now, this is what Steve Winovsky says about it. Whether RESTful HTTP will continue to displace RPC-oriented, and it's beautiful because you could just replace it now. Systems within the enterprise isn't ultimately a matter of whether one approach is technically better. Those kind of comparisons really are relative. The technology choice is never black and white. And in big picture, the time spent arguing one technology and another one is time that is generally wasted. Which brings me back to the perpetual machine. In fact, our quest to find a perfect approach where there is no trade-off and all advantages, no advantages, is like very much like building a perpetual machine, perpetual motion machine. And in fact, Leonardo da Vinci said this after spending some time, said, you seek years after perpetual motion, how many vain chimeras have you built? Go and take your place with alchemists. In 1775, the Royal Academy of the Science in Paris basically issued this statement: we will no longer accept papers or proposals for perpetual motion machine. So when is 1775, you know, in our industry where we stop looking for our silver bullet? So let's not get married to any particular technology or architectural style, but in them find opportunities to build better software. Thank you very much.